Figure 11.21 ComboBoxFrame.java. In this example, we're going to introduce a couple of new GUI components to you. We've got the JLabel class, which is typically used to display text next to another GUI component in a user interface. However, in this example, we're going to use JLabel for its ability to display an icon as well. And then separately, we're going to be talking about the JComboBox class, which is a subclass of abstract button that allows you to make a selection from a drop-down list of items. So it's a specialized button type. For JComboBox, the typical event listener will be an event listener of type item listener. So we've imported the item listener class, or interface, excuse me. And item listeners receive in their event handling methods item event objects. So we'll talk about all of those in this example. Now, before we get into all of the code, let's go ahead and run this program so you can see its functionality. In this case, we have a window that contains the JComboBox with the items that we can select from. Notice that it's displaying a scroll bar here. I purposely set the combo box to only display 3 items in its drop-down list so that I could show you that you get this free scroll bar if the list can't show all the items that you're displaying. And then separately, this is our JLabel that's displaying only one of the images. You select an image name and it will then be displayed in this JLabel. So initially, bug1.gif is the displayed image. If I make a selection of bug2.gif, I see the other bug image that we used in the last example with the yellow background. If I select travel bug, I get a different image. And notice that the GUI components moved a little bit in this case. That's because we're using a flow layout again for simplicity. So I notice the GUI components reflowing here. Normally you won't use this layout manager and you'll have much more precise control by using a GUI design tool to lay out your graphical user interface components. And then finally, I just wanted to point out that Java does support animated images, such as animated GIF images. Here you can see the little bug wings flapping on our animated bug image. All right, now that we've looked at the basic functionality, let's take a look at our source code for the ComboBoxFrame class, which extends JFrame. Again, we're creating a customized subclass of JFrame, and as in our other examples, we have a test class, which just provides a main method to launch the application. Now, in our ComboBoxFrame class, we've provided references for our JComboBox and JLabel objects. We've also got 2 arrays at lines 17 and 18, an array of names which represents the names of the image files on disk. And at lines 19 through 23, we've got an icon array called icons, in which we are initializing each icon variable in the array with a new image icon object using the same techniques we demonstrated to you in the last application. Our constructor sets up the GUI and registers our event handler. First, we use the super syntax to pass a string to the JFrame superclass constructor so that we can display a string in the title bar. And again, notice that we're setting our new subclass of JFrame objects layout to a flow layout. At line 31, we create our JComboBox, and one of several JComboBox constructors provides the ability to receive an array as its argument, and then it uses the string representations of every element in that array as the items in the JComboBox, and they're shown in the same order that they appear within the array itself. We also have a set maximum row count method for JComboBoxes, which says the maximum number of items that will be displayed in the drop-down list when the user clicks the JComboBox. In our case, we've said 3 because we have 4 items and we wanted to show you that you get a free scroll bar if you cannot display all of the items at once. Now I'm going to skip lines 34 through 46 for a moment. After we've created the GUI component, we add it to the user interface, which displays it on the window. And then separately, we create a JLabel. And notice for the JLabel that we're giving it an icon variable as its argument. If you use the JLabel constructor that takes just an icon as its argument, it will display the image represented by that icon. And then at line 50, we attach that JLabel to the user interface. So that's pretty much all of the code with the exception of lines 34 through 46, which are actually a single method call to register the item listener for our JComboBox. Here's the opening parenthesis of the function call. Here's the closing parenthesis and termination of that function call. Lines 35 through 45 are the very first anonymous inner class definition that we are creating. So what we're actually doing here, the new operator is actually creating a new object of the class that we're creating, and this class does not have a name, which is why we call it an anonymous class. So we're both creating the class and creating a new object in parallel here, and then that new object will be supplied as the argument to the addItemListener method. The addItemListener method will then take the reference to this new object of the class that we're creating and place it into the listener list for our JComboBox. Now, the syntax for an anonymous class is you start with the new keyword and you follow that immediately by either a class name or an interface name. If you follow it with a class name, then what you're saying is that you'd like to create a new object of a class that extends the class to the right of the new keyword. If you say an interface name, then you're actually saying you'd like to create a new object of a class that implements that interface. So in our case, we're using the item listener interface, and therefore what we're saying here at line 35 is we'd like a new object of an anonymous class that is implementing the item listener interface. And that means it's going to have to define the one method of item listeners, which is called item state change. Separately, the parentheses indicate a call to the default constructor for this new class, and the class's body is defined by a set of curly braces. Within the body of the class, because it is a class, you could technically have instance variables and other methods, but normally, at least for an anonymous inner class that's used for event handling, you will just implement the event listener's methods. In this case, there's only one, item state change, which must return void and must receive an item event parameter. Once I've defined that method in the body, I can say exactly what I'd like to do when this method gets called. And you'll notice that we have an if statement that says if the event, which is of type item event, if the event's getStateChange method returns a value which is equal to item event.selected, which means I've selected an item in the combo box, then what I'm going to do is tell the JLabel to set its icon to a new item in the icons array, and the item that I'm going to set it to is the one with the index specified by this highlighted expression, images.jComboBox dot get selected index. The index numbers in a JComboBox start at 0 and increase by 1 for each subsequent element. So whichever item was selected, I'm going to take the index number of that item and use it as the index number in my icons array to pick the new icon to display. Now let's go back to line 41 for a moment. The reason that we're testing this event to see what the state change value was is because every time you make a selection from a combo box, first we deselect the previously selected item and then we select the new item. So there's actually two events for every selection from a JComboBox, and I only want to change the label's icon in response to selecting a particular item. So in that case, I'm looking for the item event.selected constant as the value returned by getStateChange, and based on that, if in fact that condition is true, I will set my icon. Now, when you're first looking at this new anonymous inner class syntax, it's a little bit strange because you're actually defining a function inside of another function in your code, which is normally not allowed syntax. But you have to keep in mind, we're not really doing that. What we're doing is we're actually creating a new class here and immediately instantiating an object of that class. And this method is not something that's actually going to be called possibly at all. It depends on whether or not the user makes a selection from the images JComboBox. Now, this is an anonymous inner class a nested class, and as a nested class it does have access to things like the label variable, which we declared in our ComboBoxFrame class up here at the top of the class. It has access to the icons array, which we declared up here at the top of the class. It has access to the images JComboBox variable, which we also declared up here at the top of the class. So you can see that even an anonymous nested or inner class has access to its outer class's members, just as we had shown you with a regular nested class. The only other thing I want to point out here is the fact that, again, when you see this method defined inside of a call to another method, you have to remember that this method that we're defining at lines 38 through 44 is not being called right here. It is simply being defined at a later time once the event actually occurs on the images JComboBox. Only then will the ComboBox call this method on the event listener object.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.